It is difficult to know how to place Montesquieu if you're the kind of person who likes to categorize. Historian, political philosopher, sociologist, jurist, or, if you think the Persian letters a novel, a novelist. He was all these things. Perhaps, as some have, he could be placed among that almost extinct species, the man of letters. The books that make up the spirit of the laws have had the most influence on later thinkers, and in them, as in his equally great Considerations on the Causes of the Grandeur and Decadence of the Romans, he makes his underlying purpose clear. It is to make the random, apparently meaningless variety of events understandable. He wanted to find out what the historical truth was. His starting point, then, was this almost endless variety of morals, customs, ideas, laws and institutions, and to make some sense out of them. He believed it was not chance that ruled the world, and that beyond the chaos of accidents, there must be underlying causes that account for the apparent madness of things.
These two paintings, both called sunflowers, are generally accepted as the finest of several depictions of the thick-stemmed, nodding blooms that Van Gogh made in 1888 and 1889 during his time in Arles. The first is now in the collection of the National Gallery in London, and the second is in the Van Gogh Museum in Amsterdam. Van Gogh referred to this work as a repetition of the London painting, but art historians and curators have long been curious to know how different this repetition is from the first. Should it be considered a copy, an independent artwork, or something in between? An extensive research project conducted over the past 3 years by conservation experts at both the National Gallery and the Van Gogh Museum has concluded that this second painting was not intended as an exact copy of the original, said Ella Hendricks, a professor of conservation and restoration at the University of Amsterdam, who was the lead researcher on the project.
Okay, today's our first class, so I'd like to begin with some important definitions. We're going to use these terms all semester, so pay close attention. To begin with, chemistry is basically the study of matter. Matter is everything that makes up the universe. In this class, we're going to study the various elements and how they interact with one another. Sometimes they unite. When two or more elements unite, we call them compounds. Now, the study of chemical compounds is divided into two main branches of chemistry: organic chemistry and inorganic chemistry. Organic chemistry is the study of compounds that contain the element carbon. This basically covers, it covers all living things. Carbon is an element all living organisms have in common. As for inorganic chemistry, it's the study of non-carbon-based compounds. There are 5 differences between organic and inorganic compounds. Listen carefully to these. First, there are more than 10 million carbon compounds. That's 10 times the number of inorganic compounds.
Why are there so many carbon compounds?
Mostly because carbon bonds easily with other elements. It can also form complex groups. Got it? Okay, second, organic compounds melt and boil at lower temperatures than inorganic compounds. Third, organic compounds don't dissolve in water as easily as inorganic compounds. Fourth, organic compounds catch fire more easily than inorganic compounds. However, inorganic compounds conduct heat and electricity more easily. Finally, organic compound reactions take place at slower rates than do inorganic compound reactions.
All whales, dolphins, and porpoises are social animals, although the degree of sociability varies greatly from one species to another. Differences of behaviour have not evolved by chance. Living in close proximity to other animals has certain costs and benefits, so we can expect the group size adopted by a species to be the most suitable for its environment and lifestyle. River dolphins, for example, have a fairly simple social system, forming small groups of just a few animals, rarely more than 10. On the other hand, many of the oceanic dolphins may roam the seas in groups of thousands. Also, there can be differences within species. For example, with sperm whales, females and juveniles form groups, while adult males are solitary. Some of the reasons for living in groups include greater efficiency in searching for and catching food, benefits for mating, learning, defense, and sensory integration. Now, sensory integration is the means by which each animal contributes to the information gained by the group as a whole, and this plays an important part in defense and in the search for food. For example, if one animal discovers a shoal of fish or a hungry shark, it can immediately pass on this information to the others in the group so that all may benefit. A single animal or small group may remain unaware of the food or predator and so miss a meal or suffer an attack.
Most of us know we should rein in our energy use, but to be successful, it'd help if we knew the best way to do it. So scientists asked more than 500 people, what's the most effective thing you can do to conserve energy? The results were illuminating. More than half the participants focused on conservation by curtailment, switching off the lights, changing thermostat settings, and driving less. Only 12% went for efficiency, using compact fluorescent bulbs, insulating the house, or driving a hybrid car. But scientists say that it's actually these moves that yield the bigger energy savings. The results appear in the Proceedings of the National Academy of Sciences. The study authors think that a big factor is that curtailment's easier to imagine doing, while efforts to improve efficiency would involve, for example, doing research about new appliances or cars, and spending money up front to buy them. But if people knew more about the actual energy requirements of their activities versus the savings available through efficiency, they might be spurred to act. To quote physicist and energy expert Arthur Rosenfeld, energy efficiency is like a Saudi Arabia under our cities.
I've been given an opportunity as one of the only players, the only one right now, to be inducted in the Hall of Fame with Tommy John surgery.
The great Atlanta Braves pitcher John Smoltz at his induction ceremony in Cooperstown, New York yesterday, July 26th. He was 34 when he had the procedure in which a damaged ulnar collateral ligament in the arm is replaced by a tendon from another part of the body.
It's an epidemic. It's something that is affecting our game. It's something that I thought would cost me my career, but thanks to Dr. James Andrews and all those before him, performing the surgery with such precision has caused it to be almost a false read, like a Band-Aid you put on your arm. I want to encourage the families and parents that are out there to understand that this is not normal to have a surgery at 14 and 15 years old.
Smoltz then talked about why he thinks so many kids and early career pros wind up needing Tommy John surgery.
Every throw a kid makes today is a competitive pitch. They don't go outside. They don't have fun. They don't throw enough. But they're competing and maxing out too hard, too early, and that's why we're having these problems. So please, take care of those great future arms.
And for any parents considering elective Tommy John surgery in the hope that it'll enhance an already healthy arm and increase the chances of their kid getting to the majors, Here's what Stan Conte, Vice President of Medical Services for the LA Dodgers, said at a conference of the Society for American Baseball Research in 2014.
The parents come in and say, listen, he's throwing 78. He's not going to get a scholarship till he throws 83. Let's do the surgery so he can throw 83. This sounds ridiculous, but it's happening on a global scale. It's ridiculous.
Woodblocks used for pictorial illustration became fairly common in 15th century Europe, but had been used long before that for printing designs on textiles. Most of these were simple in design and quite crudely cut, but some were skillfully drawn and cut, while others even contained pictorial imagery. Records show that woodblock printing on fabrics was practiced by the Egyptians as early as 2000 years BC. The oldest existing printed fabric, which is Egyptian, dates from the 4th century. At the same time, the craft seems to have become widely established, even commonplace, elsewhere, for example in India, Mexico and Peru, where the same techniques continue to be practiced today. And the technique was almost certainly used by both the Japanese and the Chinese too.
Listen to part of a lecture in an economics class and answer the question. And now, class, let's switch gears and discuss a different topic. Consumer Price Index, CPI for short. If you switched on the TV and heard on the news that the CPI in Canada was 2.1%, what does that mean? In a nutshell, it means that Canadian consumers paid 2.1% more than in the previous year for the goods and services included in the CPI basket. Although prices of goods and services rise and fall over time, when prices change too dramatically, they can have negative effects on an economy. In order to tell if an economy is experiencing inflation, deflation, or stagflation, we use the CPI as a gauge of the prices of goods and services. Believe it or not, when the Department of Labor's Bureau of Labor Statistics releases the CPI data monthly, the CPI's results are widely anticipated and watched. Who would eagerly await the results, you might ask? Well, the CPI plays a role for many key financial decision-makers, including individual investors, the Bank of Canada in Canada, and the Federal Reserve in the U.S. The CPI helps the Bank of Canada forecast the interest rate policy and other decisions of major banks and corporations. I mentioned the CPI basket before, and now I want to expand on what this basket is and how we get the information. The base year market basket, which makes up the CPI, comes from detailed expenditure information collected from surveys of thousands of families. The information is not randomly collected. Instead, the information is gathered through interviews and diaries kept by participants who have agreed to disclose their buying habits. The basket is divided into 8 groups: food and beverages, housing, apparel, transportation, medical care, recreation, education and communication, and other goods and services, and includes more than 200 categories. Finally, the prices of 80,000 items in the market basket are collected monthly from thousands of retail stores, service establishments, rental units, and doctors' offices.
Listen to a lecture in a botany class. The professor is talking about plant hormones.
The word hormone is derived from a Greek verb that means to excite. Hormones are found in all multicellular organisms and function to coordinate the parts of the organism. A hormone is a chemical signal. It's produced by one part of the body and is then transported to other parts of the body, where it triggers responses in cells and tissues. The concept of chemical messengers in plants first emerged from a series of classic experiments on how plant stems respond to light. Think about this. A houseplant on a windowsill grows toward light. If you rotate the plant, it will soon reorient its growth until its leaves again face the window. The growth of a plant toward light is called phototropism. In a forest or other natural ecosystem where plants may be crowded, phototropism directs growing seedlings toward the sunlight that powers photosynthesis. Some of the earliest experiments on phototropism were conducted in the late 19th century by Charles Darwin and his son, Francis. The Darwins observed that a grass seedling could bend toward light only if the tip of the shoot was present. If the tip was removed, the shoot would not curve toward light. The seedling would also fail to grow toward light if the tip was covered with an opaque cap. The Darwins proposed the hypothesis that some signal was transmitted downward from the tip into the part of the stem that controlled growth. Later experiments by other scientists studying phototropism led to the discovery of chemical messengers that stimulated growth in the stem. These chemical messengers were hormones.
Through 2. Listen to part of a talk in a science class.
As you recall from our previous discussion, the chemistry of life is organized into metabolic pathways. Next year in your organic chemistry lab, you'll go into metabolism, in more depth. Since this is an intro course, you need only a general understanding of the process for now. There's a wonderful videotape I'd like you to know about that will help you review for the test next week. It's part of the Transformations series that was on television about a year ago. The episode you should watch is called The Industry of a Cell. I strongly urge you to see it. I believe our library has more than one copy. It shows lots of examples, the many ways that cells use energy for metabolism. For example, it shows how bacteria in the headlight of a certain fish, how these bacteria take the energy stored in food and convert it into light in a process called bioluminescence. You should all try to see this program before next week. I highly recommend it. In fact, you can expect to see examples from it on the test.